Given that vector A has magnitude 6 and is directed towards standard angle 60 degrees, and vector B has magnitude 6 and is directed towards standard angle 180 degrees, find the magnitude and angle of the vector D, where vector D is equal to vector A plus vector B, and then it says to report the angle in degrees and round both answers, that is the magnitude and the angle, to the tenths place. Now, I've taken the liberty of already drawing a sketch of these two vectors, and what I'd like to do is I want to actually take the approach to this problem to first do a geometric approach, because when you do vector addition based on what we've learned so far, you can do head to tail and apply geometry, or you can go into components and apply what we've learned about the fact that when you have a vector equation such as a sum, you can just do that to the component. So it kind of gives you two options here, and I'd like to again explore both of those. This one's kind of set up though. These two vectors are the same length, and they're kind of at some special angles that the geometry one won't be that bad. So what I'm going to do is I'm going to paste over another copy of these two vectors so I can manipulate them. And what I'd like to start out with in terms of manipulation is I'm going to take this vector B here and move it over to the end of vector A. And I always get real picky with where I want to put it, but I'm trying to get as close as I can. Oh, that's going to have to be good enough. Let me actually move this whole thing over just a tiny little bit, if I can. Hopefully, yeah, okay, that's probably a little bit better looking. And what we can see from this is like, this is the head to tail for A and B. That means that the vector here between sort of the two gaps, I'm kind of drawing a little bit side from it there, but that roughly is what I think vector, let me make that D look a little bit nicer. That's what I think vector D is right there. And now, does that answer the question just to draw a picture of it? Well, I'm asked for the magnitude and the angle, so I'm going to have to do something to figure those out. So what can I do? Well, I know that vector A is directed at 60 degrees, so I'm going to draw like some dotted lines here, because this is not a vector. I'm just using this for reference. So that's meant to be like a horizontal reference right there. And then I'm going to state, well, hey, this angle right here is 60 degrees. And B is also horizontal, just like this horizontal reference was. So B and this dotted line are parallel to each other. That means that this angle over here is also 60 degrees. There's a theorem in geometry. That may also just be obvious looking at the picture, that if two lines are parallel and you have something going through it, which actually is vector A here, but if it were another line, this angle would have to be the same as that one. So that's what I'm using to look at that. And we know that B has a magnitude of 6 and A has a magnitude of 6. Boy, this is really starting to look very symmetric here. It's really looking like you've got an isosceles triangle with a vertex of 60 degrees. And if I could maybe argue something about like these two angles and then look at this other length here, wouldn't it make sense if D was just equal to 6? Wouldn't that be really super cool? Well, one way to see that is, since it's isosceles, these two angles right here have to be equal to each other. These two right here have to be equal to each other, right? But the sum of the angles needs to be equal to 180 degrees, and since there's already 60 here, that means these two must sum to 120, but they're equal, so each one must be 60. So that means all three angles are equal, which means all sides must be equal, and therefore the magnitude D is equal to 6. Now, the only other thing that we're kind of on the hook for in terms of our answer is to state as an angle what the direction. So maybe I'll call that theta sub D here just to be really clear what I'm doing. What do I think that is? Well, I know that this angle is 60 degrees. I've just argued this base angle is equal to all these other 60 degrees. That's another 60 degrees. 60 plus 60 is 120. That, I think, corresponds to the standard angle description for vector D. So I'm going to go out on a limb here, maybe not too much out on a limb, really. I'm pretty confident that 120 degrees is the answer to that. Now, maybe to check that everything I did here was legitimate, even though I'm pretty confident these are the correct answers. But I'm going to look at this in terms of components. How would you do this in terms of components? Well, what you'd be on the hook for is you'd want to calculate the components for A, both of them, both the X and the Y, and you'd want to also do it for B. And then I'm going to employ that technique that we've done in the last couple examples where if I have a vector equation, I can just use the component equations to get the components of D for each one of these. But we have to do this in steps. So if you're doing this, and we're going to see some other ones like this, we're going to have to do it this way, because not all of them, not every problem turns out so nice and symmetric as this one did. And generally speaking, if that's the case, this is like your default method to go to if it's not easy. So it's good to already kind of get our feet wet with it. So the formula though for this for the x component, is A cosine of the angle, and maybe I'll just, I don't know, this should be the angle for A. Maybe I'll put that subscript to make things clear. The other one, y, is going to be a sine of that angle, and in this case, given the information that we have given to us, that is going to be 6 times the cosine of 60 degrees. Now, hopefully, does everyone know what the cosine? If you don't, just put this in your calculator. If you don't remember what cosine of 60 degrees is, that is a special one. You know, nobody knows all cosine without values for every angle without using their calculator anyway. So again, feel free to use a calculator. I happen to know this one's equal to 1/2, and that therefore the answer here is equal to 3. This next one here is going to be 6. Now it's sine of 60 degrees. Sine of 60 is a little bit trickier. It's not 1/2, but it's √3 over 2. So I think that would actually, like in a very exact form, would simplify to 3√3. But if you did this on a calculator and just wrote a decimal for this and tried not to, kept enough to not avoid round off error, that's fine. 2, perfectly fine by me. In other words, how do we do the B ones? We could use these same formulas, but I think the fact that it's perfectly horizontal makes it a little bit more obvious that the x component should be 6 and the y component should be 0. Can anyone spot a mistake I just made? Pause for 2 seconds here. B points to the left, right? And left is the direction for negative along the x-axis. So this should actually be a -6. And in that sense, if you did cosine of 180 degrees, you actually get -1 would be how you could arrive at if you used these formulas. But that gives me all of these components. So in that sense, if I want to find the components for the vector D, I'm just going to sum up the x components. Sum up the x components first. I accidentally hit a button there. I shouldn't have. Plus, so that's 3 plus -6, which is equal to -3. And then for the y component, we're going to do just 3√3 plus 0. And again, really, we're just adding up the components of a and b respectively for x's and y's, and this of course winds up being 3√3. And then if you wanted to, you could go into that formula that for d, for the magnitude, is equal to the square root of d sub x squared plus d sub y squared. I think I'm just going to go ahead, since I've been working with numbers here, I'm just going to go ahead and put those in as numbers. So that's going to be 3 squared plus 3√3, and that whole thing should be squared. Now, a question that might come up, I like to do this way, but some people might say, wait a minute, that was a minus right there. Should I put in a minus right here? You can, but if you do, put parentheses, because it's not -3 squared, it's -3 all squared. This whole term in here should be positive and shouldn't be negative at all, because square of any number is always going to be positive. If you actually put this into your calculator, or maybe if you're just really good at doing this kind of math, the answer does turn out to be exactly 6, which matches what I got earlier. And then if I want to find, like, how do I find the angle? I'm maybe a little low on space here, but anyway, for the angle for D, you could just do tangent inverse of, and you'd want to do the y component over the x component. So I think that would be a tangent inverse if I'm kind of doing a little math in my head, but I'm thinking 3√3 over -3, just -√3 right there. And you should, let's actually, well, what would you get with this? I think you actually get like -60 degrees for that, but then you have to recognize, okay, plus, so this kind of situation comes up. The principal value for tangent, oops, I think I forgot an equal sign there, sorry about that, but the principal value of the tangent for the tangent inverse function is normally in either the first or the fourth quadrant. So your calculator would give you this value, and then you have to know, based on the fact that this one is actually in the second quadrant, oh, whoops, I have to add 180 to that in order to get 120. And then the answer matches what I got using the geometric method. So let's go ahead and check those answers. There they are. It looks like it all worked.